this video. Woo, woo, woo. Since I ran out of time just as we were getting to the graph, I just made another video for today. So if you're here, awesome. Let's keep going. And since I'm making another video anyway, I'll probably just walk you through some of the homework problems. So feel free to try some of them and pause the video and then check your answer with what I get. Okay. So we were just getting to graphing this last one here, letter D here, where we got no real solution because I got a negative under that root. And we know that we can't square root a negative in the real number system. Okay. So I just wanted to let you know what that will look like if you try to graph it. Notice the parabola is way up here, right? The lowest point, the vertex, is not crossing the x-axis at all. So there are no x-intercepts in the real number system. So what you should say when that happens is no real solution, because what we get when we square root a negative is an imaginary number. And we won't really talk too much about those in Algebra 1, maybe a little bit, but you will learn about them at a later math course, okay? So stay tuned for that. Cool. So first one on the homework here, folks, it looks like we are again solving quadratics for their roots, and you can use any method you like. So scroll up to remember our 3 different methods we can use here and pick which one you like the most. I would say when I see icky numbers, I might go do a quad form, just because I don't sometimes like to think about factors of big numbers. So that would be my piece of advice, but you can pick any method, and you theoretically, as long as you do the method correctly, you should get the same answer. Okay. So for the letter A here, folks, I'm going to try to factor this one. We haven't factored in a while. I kind of miss it. And just because the A is 1, so I figured it would probably be an easy-ish factor. All right, so what multiplies to a positive 42 but adds to a negative 13? And again, if you don't like playing this game, this diamond game, go right for the quad formula, okay? But what multiplies to 42? It's got to be 2 negatives, and I believe it's going to be negative 6 times negative 7. Negative 6 times negative 7 gives me a positive 42. Let me just double check. All right, good. All right, so now let's divide and slide. Negative 6 divided by 1 is negative 6. Negative 7 divided by 1 is negative 7. And now we're going to use ZPP, the zero product property. Tells me one of these factors has to be equal to 0. So I just set them both equal to 0. And I notice that it's always going to be the opposite. So since my factor was an x minus 7, my root is a positive 7. All right, so that was pretty nice. For this second one, folks, I'm going to use the quad formula because I notice my A is 3, and sometimes when my A isn't 1, it makes factoring a little trickier. So for this one, I'm going to go ahead and make sure I'm checking that it's in standard form and checking for greatest common factors. But then I'm going to jump in and do the quad formula for this one. And I believe this one does factor out. So if you'd like to use the same method we did in part A, you totally can. So it's the opposite of B plus or minus B squared minus 4AC all over 2A. So all over 2 times 3. Okay. So I'm going to find the discriminant. So I'm going to figure out what's under this root. 10 times 10 is 100. So I'm going to do 100 minus 4 times 3 times negative 8. All right. So my discriminant is 196. All right. So the square root of 196 is what I'm looking at here. So now I'm going to break it into my 2 separate solutions. So my first one is negative 10 plus the square root of 196 divided by 6. And my second one is going to be negative 10 minus 196 divided by 6, okay? So let's clean this up a little bit. What's the square root of 196? You guys are probably going to get pretty good at your roots, but if you don't know, I think, yeah, you'll get better at it. 196 is 14, but I'll just kind of, square root of 196 is 14. I was right. Woo woo. Okay. It's the little things in life. Negative 10 plus 14 divided by 6. Okay, so negative 10 plus 14 will give me 4 in the numerator and 6 in the denominator. So I'm going to divide top and bottom by 2 to reduce this fraction, and I will get my first x-intercept is 2/3. Okay, now let's do the same thing over here. So we'll do negative 10 minus 14 divided by 6, which gives me negative 24 divided by 6, which gives me negative 24 divided by 6 gives me negative 4. I don't know why I couldn't do that in my head. I don't know what's going on with my brain today. So my two answers are 2/3 and negative 4. Those are my two roots. And if you ever want to check your answer, you always can graph it and make sure that the x-intercepts line up. Alrighty, so for part C, this one is one of those two-termers. So remember I talked about, like, whenever you have a binomial, it's always good to look for a greatest common factor. And right away, I see that they're both divisible by 2. So I know that I can take a 2 out front. And then I notice they both also have x's as well. So I'm going to set out 2x out front. And then if I divide that, what am I left with? I'm left with just x minus 5, okay? Equals 0. Now that it's factored, I can pretty easily use zero product property. So my first x-intercept is 0. Remember, anytime you have like an x out front, one of your x-intercepts will be 0. So that's just something to look for. And then my other one will be positive 5. All right, for this one, I'm noticing a greatest common factor of, I believe, 4, right? 60 divided by 4, yep. So I'm going to take out a positive 4 out front, and so I'm basically dividing everything by 4. And so I get plus 2x minus 15 equals 0. And so now to factor what's left after I factored out my greatest common factor, you can use whatever method you like. Since the numbers are pretty teeny, I'm going to use the factoring. So my A is 1, my B is 2, and then my A times C would be negative 15. So what multiplies to a negative 15 but adds to 2? That's going to be 5 and 3. And since my sum is positive, the 2 is positive, the bigger number has to be positive. So the smaller number there is going to be negative. So 4 stays out front, and then I have what? 5 divided by 1 and negative 3 divided by 1. So here's the zero product property. 4 equals 0, never. So I need x plus 5 to equal 0 or x minus 3 to equal 0. And these are just going to be the opposites here. So I get x equals negative 5 and x equals a positive 3 for that one. Cool. So that's kind of nice. So you can see this one, the method we used is GCF and the zero product property. This one we factored. This one we used quad, right? And you could have used a different method, folks, and you still should have gotten the same roots that I did. So kind of cool that you get to pick how you like to solve these ones, okay? So 9-19 to close out our assignment today. Does a quadratic equation always have two solutions? That is, does a parabola always intersect the x-axis twice? Well, we already know the answer to this, right, guys? We know that the answer is no, because we saw it in letter D up here. Oops, sorry, scrolled too much. Letter D, there was no real solution. There was no x-intercepts, right? So we know it's not always possible. So let's see. Letter A wants us to draw an example of a parabola that only intersects the x-axis once. All right, so pick your favorite x number. I like the number 2. All right, so my parabola is only going to intersect at 2, 0, right? So here it is. Here's my U shape. So the only x-intercept is 2, 0. So is that possible? Heck yeah, there it is. It's when the vertex is right on the x-axis that makes there only one x-intercept, right? It only crosses the x-axis once. If possible, draw an example of a parabola that never intersects the x-axis. So this is going to be that one that, that I graphed, right? I could sketch this exact parabola right here that I have in purple, where the vertex is just kind of hanging out up here, right? And my parabola just keeps going on forever and ever upwards. So I know that it will never turn around and come across the x-axis. So it's possible to get two solutions. It's possible to get one solution, and it's possible to get 0 roots, okay? So this is kind of an extra little tidbit for those of you who want some more math, right? So the way that this works is if my discriminant, if what's under my root is a positive number, that means, oops, someone's calling me. Positive under the square root, that means I have 2 solutions or 2 roots. If what's under the square root is 0, I'm only going to get 1 solution because then I'm adding or subtracting 0, which is just 0. And then if what's under the root is negative, that's when you have no real solution. So that's kind of a nice way that discriminant really allows you to see how many solutions, how many roots, how many x-intercepts. All of those are the same thing, same idea, right? Roots, x-intercepts, same thing. So the discriminant really tells you what to expect that way. If it's positive, you're going to have 2 x-intercepts. If your discriminant is 0, you're only going to have 1. So that would be like this case here. And if it's negative, you're going to have no real solutions. You're going to have no x-intercepts in the real number system. All right. So hope this was helpful, folks. We'll catch you back here next week. Let us know if you have any questions on the quadratic formula. There's lots of resources online. If you even just want more problems, just Google search it. Otherwise, have a fantastic day, guys.